Chapter 11, Lesson 9, we are discussing sine and cosine, the other half of our trigonometry lesson. So remember that in tangent ratio, we did not use the hypotenuse at all. We only used the two legs. Well, with the sine and the cosine now, we will be using one leg and the hypotenuse for each of these. So the simple formula to write down in your book is that the sine of A equals opposite leg over hypotenuse, and that the cosine of A will be the adjacent leg over the hypotenuse. So if I'm talking about, there we go. I'm talking about the angle A right here. The leg that is opposite is lowercase a, because remember a leg is a length, right? And the hypotenuse is C. It's always the longest side of the triangle. Now, if I'm talking about the cosine of A, that is the leg that is adjacent to A, which would be B, over the hypotenuse, which is C, which is what they have written here. All right, so we have this acronym that we use to try to help you remember which ratios to use. So the acronym is called SOHCAHTOA. And basically what that's standing for is that the sine of A is the opposite leg over the hypotenuse. The cosine of A is the adjacent leg over the hypotenuse. And the tangent of A is the opposite leg over the adjacent leg. So they're just using the first letter of each thing. So like SOH, S-O-H, so. Cosine, adjacent hypotenuse. Tangent, TOA, like that. So if that helps you, go ahead and write that acronym in your notebook. All right, so looking at this triangle here, and the first thing I always like to do with trigonometry problems is always go ahead and circle the hypotenuse. So 17 is the hypotenuse. It's the longest side of the triangle. It measures 17 units, whatever that is. Remember, the hypotenuse always has to be on the bottom of a fraction if you're going to use it. Hypotenuse is always on the bottom. It's always something over hypotenuse. All right, so the first one's asking for the sine of A. And if I do my SOHCAHTOA, remember the sine is opposite over hypotenuse. So which leg is opposite from A? Side BC, which is 8 units, over the hypotenuse, which is 17. The cosine of A is the leg that's next to A. So this is the leg AC here. This is next to A, which is 15, over the hypotenuse, which is 17. Then I'm going to do the sine for B. So an angle B, I look across the triangle, is 15, over the hypotenuse, which is 17. And the cosine of B, right next to B, is 8, over hypotenuse is 17. Okay, I'm going to go ahead here and just circle these hypotenuse. All right, this first one says sine ratio for A and B. So I'm doing sine of A and sine of B. So the sine of A is opposite, which is 9 over 15. For B, the opposite is 12, hypotenuse 15. Sine of A for this problem across the triangle is 5, hypotenuse is 13. Sine for B across the triangle is 12, hypotenuse 13. Now we're doing cosine. So remember, for cosine, we're doing the CAH, so it's adjacent over hypotenuse, So cosine for A, what's right next to the A? 12. Hypotenuse, 15. Cosine for B, what's right next to the B? 9. Hypotenuse, 15. Cosine for A, what's right next to the A? 12. Hypotenuse, 13. Cosine for B, what's right next to the B? 5. Hypotenuse, 13. Find the missing lengths and angle measures. So remember, if we're missing legs, we're going to use regular cosine and sine. And if we're missing angles, we're going to use inverse cosine, inverse sine. So in number 5, we are missing an angle. So, actually we're missing a bunch. I see. We're missing a side, and an angle. Let's start with the missing sides. So this missing side is the hypotenuse. If I'm going to look for the missing hypotenuse, I can only use sine or cosine. So I look at this 36 and the side across and the side adjacent to it. In the side opposite from the 36, I have a 7. Adjacent to it, I have nothing. So I can't have two variables. If I'm looking for the hypotenuse, I have to have a number, two numbers. So I know that I'm going to use sine. So I'm going to set up the sine of 36 equal to 7 over c. Again, I can only have one variable in my equation if I'm looking for something. If you have two variables, you've done the wrong equation. Put this over 1. C times sine 36 equals 7. Divide by the sine 36. And 7 divided by sine 36 is 11.9. Okay, now I will go ahead and try to look for A. So looking at A, there we go. Okay, looking at A and the 7, notice I do not use the hypotenuse, so I'm going to use tangent. Tangent of 36 equals opposite over adjacent, so 7 over A. Then A times tangent 36 equals 7. Divide by the tangent 36. And A is 9.6. Okay, last thing I need to do is find this missing angle. Now, I do know that 3 angles of a triangle add up to 180. So I could just take 180 minus 36 minus 90 and get 54. But because we are working on these trigonometry ratios, I'm actually going to use a trig ratio to solve for it. So if I want to use tangent, and because I have all 3 sides, I could use any of the trigonometry ratios, the sine, cosine, or the tangent. I'm just choosing to use tangent because I like that one the best. So I'm going to say the tangent of angle X is 9.6 over 7. Since I'm looking for an angle, I'm going to do the inverse tangent to both sides. So I have 9.6 over 7. So inverse tangent, 9.6 over 7. And I already knew I was going to get 54. Okay, same thing for number 6. I don't have the hypotenuse. So to start off, I'm going to have to use either sine or cosine. So I look at the information I'm given. I'm given a 62, and I'm given the side right next to it. So I have to use cosine. So the cosine of 62 is adjacent over hypotenuse. So I'm going to be dividing 8 by cosine 62, and I get C to be 17. Then if I want to look for A, notice that from the 62, A is opposite, and again, the 8 is adjacent. So I'm going to use tangent. 62 equals opposite over adjacent. This time I'm going to take 8 times the tangent 62, which is 15. And I could just use the fact that a triangle adds up to 180. So I know that that missing angle should be 180 minus 90 minus 62. So I know it should be 28, but I'm going to use, since I know all of the sides, it doesn't matter. I'll just choose sine this time. So if I'm looking for an x and I'm choosing to use the sine of x is 8 over the hypotenuse, which is 17. And now, since I'm looking for an angle, I'm going to do the inverse sine of 8 over 17. And I already knew it was going to be 28 degrees. Okay, on this one, I have two sides and I'm missing the both angles. So if I look at angle X, I want to solve for that one first. I have 9 across or opposite from it, and 15 is the hypotenuse. So if I have opposite and hypotenuse, I have to use sine. Sine of X equals 9 over 15. Inverse sine of 9 over 15 is 36.9 degrees. Then I'll just use the fact that this is a triangle that adds up to 180. So I'm going to do 180 minus 90 minus 39.6 to get 53.1. Now I'm missing side A, and so I'm going to use angle X, which is at 36.9. A is right next to it, and 9 is opposite from it, so I'm going to use tangent. So take 9 divided by the tangent of 36.9 to get side A to be 11, basically 12. Rounds up to 12. Same thing here. If I'm going to look for Y, the 21 is opposite from the Y and the 20 is next to it. So it's tangent, opposite over adjacent. And since I'm looking for an angle, I'm doing the inverse tangent of 21 over 20. So Y is 46.4 degrees. I'm going to use the fact that it's a triangle to save myself some time. 43.6 degrees. And then in order to find C, which is the hypotenuse, I'm going to set up adjacent and hypotenuse. So cosine of 46.4 equals adjacent over hypotenuse. So I need to divide 20 divided by the cosine of 46.4 is 29. A 200-foot long wire is strung to the top of a 75-foot tower. What angle does the wire make with the ground? So this is a 200-foot wire, 75-foot tower, and they want the angle that's at the ground. So this is the hypotenuse. The 75 is across or opposite from the X. So I'm going to have to use sine since I have opposite and hypotenuse. Sine of X equals opposite over hypotenuse. So use inverse sine since I'm looking for an angle. And I get that the angle is 22 degrees. The base angles of an isosceles triangle are 28. The congruent sides are 14. Find the area of the triangle. Well, if I'm looking for the area of the triangle, my formula is half the base times the height. First of all, I'm going to need the height. And this is a hypotenuse then of this right triangle. The height would be opposite from the 28. So I'm going to use sine 28 equals height over 14. 14 sine 28 is 6.6. Don't know what the base is yet, but the height is 6.6. Okay, now if I'm looking for the base here, that's adjacent to the 28. And I still have the hypotenuse, so I'm going to use cosine 28 this time is the base over hypotenuse. 14 cosine 28 is 12.4. But I need the whole base of the triangle. So I'm going to multiply that by 2 to get 24.8 for a whole base of the triangle. All right, then half the base, which is 24.8, times the height, which is 6.6, gives me a total area of 81.84.